The following elastic potential energy examples demonstrate its impact on different aspects of daily life. An archer, stretched bow coiled spring wind-up toy prosthetic leg diving board rubber band bouncing ball bungee cord trampoline slingshot sponge mousetrap. An archer, stretched bow. Until the bow is released, the energy used to bend it back is stored as elastic potential energy. When the bow is released, the elastic potential energy in the bow is immediately converted into kinetic energy in the arrow. Arrow is stretchy too. When the string pulls on the arrow, it bends and flies off the string when the bow returns to its original position. Coiled spring. Spring is the best example when considering elastic potential energy. Stretching or compressing the spring stores the energy as elastic potential energy. Spring can be stretched or compressed for an extended period without losing energy. This characteristic of spring may be used as a shock absorber in mechanical devices, such as cars, to minimize the effect of rough roads on passengers. Wind-up toy. The key in a wound-up clockwork toy is stiff and difficult to turn. When you turn the key, you're restoring energy by tightening the mainspring, a strong metal spring. Your energy does not vanish while working on it. Instead, it is stored as elastic potential energy. When you release the key, the energy stored in the mainspring transforms into kinetic energy, which powers the toy. A wind-up clock or watch uses the exact mechanism. Prosthetic leg. Prosthesis wearers who desire to participate in recreational sports typically utilize a running prosthesis. Prosthetic running legs are made to store energy in elastic potential energy and then convert it to kinetic energy. As soon as the foot touches the ground, it bends and springs back into its original shape. The runner is pushed ahead by the elastic potential energy that is transformed into kinetic energy. Diving board. Diving boards are used for diving and are also known as springboards since they are made of springs. One end of the diving board is hinged, while the other is hung over a swimming pole. Divers can gain velocity by using diving boards. As the diver falls onto the diving board, he will exert force due to his mass. As a result, the board's spring will compress. This spring compression will be stored as elastic potential energy. The accumulated potential energy will be released and converted into kinetic energy when the diving board oscillates. Now the board is pushing the diver up with tremendous force. The board's torque assists the diver in spinning in the air. Rubber band. Rubber bands have elastic properties, which means that when they are stretched or twisted, they return to their original shape. It may be used to connect multiple objects. Rubber bands may be used to make a toy plane. A rubber band wounds the propeller of a toy plane because it stores energy in its winding. The propeller rotates as you throw the airplane, providing thrust to the aircraft by converting elastic potential energy stored in the rubber band into kinetic energy. Bouncing ball. When a ball composed of elastic material, such as rubber, strikes the ground, its kinetic energy is converted into elastic potential energy. After that, this energy is converted back into kinetic energy, causing the ball to bounce higher. Rubber balls have the highest bouncing ability. The elastic potential energy stored in the ball will cause it to bounce off the brick wall when it contracts. Tennis balls and rackets are both elastic. When the ball collides with the racket, it compresses and changes shape from round to oval, storing energy as elastic potential energy. The ball will fly forward after the bent racket and ball have regained their original form. When you replaying golf or basketball, the same things happen. Bungee cord. Bungee jumpers have energy in the form of gravitational potential energy when they leap from great heights. They in motion when they jump. The energy has now been transformed into kinetic energy. We all know that energy is conserved at all times, and this is one of the most fundamental principles of nature in the universe. So when the jumper comes to a halt, this kinetic energy must go somewhere. When movement stops abruptly, it causes higher energy through the jumper's body, leading to internal injury and psychological trauma. The elastic cord is therefore used to absorb kinetic energy significantly and store it in the form of elastic potential energy that saves the jumper's life. Trampoline. Jumping on a trampoline is both entertaining and soothing. Trampoline leaping is an excellent example of energy saving. It demonstrates how energy moves from potential to kinetic energy. Gravity gives you kinetic energy when you jump on a trampoline. When you jump on the trampoline, the mat begins to stretch downward, converting kinetic energy into elastic potential energy. The elastic potential energy has now been converted to kinetic energy, causing you to bounce on the trampoline. When you jump with another person, you provide double the kinetic energy when you land on the mat. It implies that the spring attached to the mat will gain double the potential energy, resulting in double the bounce. Slingshot. Slingshot's objective is to shoot a projectile at a rapid rate. A specific type of rubber band is utilized to attain this aim. The projectile can be pulled using muscular energy. The more you pull it back, the more elastic potential energy is created. The more stored elastic energy will convert into more kinetic energy, which will provide a higher speed to the projectile. Catapults work on the same principle as slingshots. Catapults are used to propel aircraft over short distances when there is no runway. Furthermore, it has been used as a weapon in the military from ancient times. Sponge. The sponge is a robust absorber of water and possesses elasticity. Using a sponge to remove the water from a damp surface is a fantastic idea. After that, you may remove the water by squishing or twisting it. The sponge will contain elastic potential energy during this process, and once the force is removed, it will return to its original shape. Mousetrap. The purpose of a mousetrap is to catch the mouse. They are generally placed in areas where there is evidence of mouse activity indoors. The mousetrap is placed near the prey so that the mouse is drawn to it by its smell. The stretched spring's accumulated elastic potential energy is converted into kinetic energy as the mouse approaches the prey. Due to kinetic energy, the door will be closed and the mouse will be caught. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.